Hello everyone and welcome to the Java Code Camp. If you like coding, then you've come to the right place. In this bootcamp of Global Coding sessions, we're going to be learning and coding live together for 4 weeks every Thursday. But first, let me introduce myself. My name is Mati. I'm a software engineer. I'm passionate about learning new technologies and teaching about them as well. And here at Globant, I am a subject matter expert and I'm based in the UK. But before we dive into the first session, let me show you a brief introduction about what we do at Globant.
995!
Hey, psst, Chris,
996!
what's happening?
Mark's about to reach 1,000 slides on the new client presentation.
What?
997! 998!
Oh, I need to highlight product delivery. Get me an incomprehensible graphic ASAP.
The forbidden charts.
999! $1,000!
Oh, wait, I didn't save it. Okay, it's saved. Okay, all right, it's over. There we go.
Meet the future of digital transformation. Globant. Seek reinvention.
So true. I wanted to show you this video because it is a great representation of what we do here at Globant, the culture of have fun and seek reinvention that we have. All right, so let's start with the Java Code Camp. Okay, so what is functional programming? Functional programming is a paradigm that views computer programs as the application of composed functions. And if as Java developers, we're not used to thinking of programs as the execution of composed functions. We rather think of the execution of steps or statements, as we have here in the example. This program here is a series of steps, but we can also see it as a composition of functions. For example, we have the function f and the function g. We can execute them in order, or we can compose them like we did here, and we get the same result. And functional programming is more about seeing programs like this. And what are the building blocks of functional programming? First, we have types. Types are everything that a value can be. For example, an integer, a string, a double, that kind of things are types. And we can create our own types as well, composing multiple types that we have available. Then we have values, and values are the minimal expression, anything that cannot be reduced to more, and nothing can be reduced more to it than a value. For example, if you have the value 1, you cannot reduce that even more. It's just a value. And then we have expressions. Expressions are a way of combining values with operations. So if we have two values and we operate them with the addition, for example, if we have 1 and 1, and we add the addition operation, so 1 plus 1, then we get 2. It's a different value. We have to evaluate the expression to get the new value. And finally, we have functions. And functions are nothing more than a set of expressions that we want to name so that we can reuse them. For example, if we have the addition and then the multiplication of things, and if we want to repeat this every time, we can create a function and then just call that function instead of writing all the set of instructions or expressions that we want to execute. In here, we have the features of functional programming. So the first feature is that functions are first-class citizens. What do we mean by that? It means that functions are objects that can be sent as parameters and be returned as output. In functional programming languages, functions are not just a structure of the language. They're actual objects that we can use and reuse, and we can send as parameters. We can apply to different values. We can save as variables as well. We can do all sorts of things. That's why we call them first-class citizens. Then we have data immutability. And this means that we want to keep data unmodified. Why do we do that? We want to do that to keep something called referential transparency. And this is just a fancy term for knowing always what a variable has. If we declare a variable x, we want to know that x will always hold the same value and it will not be modified ever. And this gives us a lot of advantages. For example, it allows us to be sure that it will not be modified, so there will be no race conditions if the variable is used by multiple threads. And we can be sure that if we send this as a parameter to any function, this value will never be modified. And then we have the pure functions feature, which basically means that we have a pure functions as the building blocks of this functional paradigm. Pure functions are basically functions that return always the same output for the same input. If you send a value as an input, you will always get the same value as an output. And that is what a mathematical function is. If you ask a mathematician, what is a pure function? They will tell you, I don't know. There are things that are functions and there are things that are not functions. But there's no such thing as a pure function. And that's because the pure function is a concept of computer science. And it's probably because we have been calling functions things that are not functions really, or more like procedures. Before we go on, let me tell you that if you have any questions during the presentation, I or anyone from Globant will be responding these questions on the chat. So let's go on. Let's look at the advantages of using functional programming. First, we have the fact that functional programming languages are more declarative. They are declarative languages. They favor telling the computer what you have to do instead of how you have to do it. So you will see less for loops, ifs, switch statements, and that kind of things. And you will favor different kinds of control structures, more declarative control structures, instead of flow control structures. Then it's also simpler to write. Because it's more declarative, it's simpler to write the code. And it's also very easy to test. And if you love TDD as I do, then you'll probably really love functional programming. And how does Java support functional programming? Okay, since Java 8, we've seen the introduction of many features in the Java language to support functional programming features. The main one, I guess, it's functional interfaces, in which we basically have the ability to implement interfaces with anonymous functions. And this is the second point, which is the lambda expressions. Lambda expressions are implementations of interfaces with anonymous functions. In the old days, we had to do anonymous classes, which were very verbose and very hard to read. But with lambda expressions and method references, it has become so easy to implement interfaces that have only one method. And then they have also introduced a lot of data structures and functions, and as higher order functions. We have the Stream API, completable future, optional, and many other features that will support functional programming. And we will be seeing all of this in this Java Code Camp. So, is then Java a functional programming language? I would say not quite. Even though they have introduced a lot of different features for functional programming, Java is a multi-paradigm programming language, and that means it's not purely functional, and it hasn't been designed as a functional programming language. So there are features of pure functional programming languages that Java doesn't have. For example, the support for recursion in Java is not great. It's not easy to keep truly immutable data in Java. For example, if you have classes that have lists inside, and these lists have in turn also lists and that kind of things, it's hard to be sure that these lists will not be modified, or the data inside the list will not be modified. There are also some functional patterns that can be used in Java, but when you use them, you realize that it makes the code harder to read or to write because the language was not designed for those patterns. And finally, there are libraries that make Java more functional, and they have their own implementations of immutable collections and immutable data. So you can look up for those libraries. It will make it easier. But what I like to do here is use a pragmatic approach to functional programming. We're not going to be using functional programming in the pure sense. We're going to be learning the most useful features and the features that we can use in Java so that we can improve our coding style. I can assure you that if you follow along, your coding style will increase in quality massively, and everyone in your team will be grateful for that. All right, so we are getting to our tutorial. So as always, I like to explain these concepts using tutorials because I feel like this is the easiest way to explain things. It's to get to the code and get cracking and start learning by doing. So in this tutorial, we are going to be doing this tutorial that is called paths. And it's basically, imagine you have some sort of Google Maps kind of API that returns a list of paths to get from one point to another. And each path will have segments, and each segment is composed by 2 points. Each point will have only 2 values, x and y. So it's a 2-dimensional map, which to make it easy. And then we will develop a function to figure out which is the shortest path in the list. And finally, we will also figure out which is the shortest path in a list that includes a particular set of points. So we have a lot of coding to do. So let's move into the code. I have created here an empty project for Java. I'm using Java 17. So we will be using and looking at many of the new features of Java. And this is a great opportunity for you guys to also learn new things about Java, not just functional. And I, as a TDD developer, we will also be doing a lot of testing because I believe TDD is the best way you can approach coding. So the first thing I want to do is I want to create a class called point. This will represent the points, and it will have two fields, and let's create it here. point, and I will create it as a Java record. I don't know if you're familiar with record, but basically this is a new feature in Java. I think it's available since Java 14, and it's basically a more concise way to create classes which have immutable data, and in other languages they are called data classes, like in Kotlin, for example. So the syntax is similar to what we use in classes, but it's more concise and easier to use. For example, in here we'll be using big decimal for our values just to make it interesting. So we have two fields, x and big decimal y, right? And this is our first class. So instead of declaring the fields here as private and big decimal x, we declare the fields here, and they are by default. By default, they are private, but they have accessor fields. So I can access x and y for reading the values, and it also has by default it has implemented the equals and the toString method, so it's very convenient. Another thing that we used to do a lot in the past is use Project Lombok, and I think this feature is trying to replace that library. So I really like using records, and it goes really well with functional programming because records are immutable. So the first thing we have to do is we have to create a method here to calculate the distance between 2 points. So let's create one method which will be public. It will return a big decimal, which is a distance, and it's called distance. It will receive a point as a parameter. And let me do a brief comment here. Usually, functional programming doesn't use classes and methods. We tend to use data and functions. But because Java is an object-oriented language, I will be using this kind of notation. I mean, if you use it in the right way, we can still call this a functional method. There are many features of the object-oriented programming language that we won't be using, like, for example, inheritance. We tend to avoid inheritance when we do functional programming. But I still like using methods and some sort of encapsulation for functions. So as I told you before, I want to create a test for this. I'm going to create a test. In IntelliJ, it's really easy to test to do this. You can do option enter, and you get the option to create a test. And it creates the test in the right folder, everything for you. And I'm going to start creating my test. Void test distance. And I'm going to create one test when the other point is null. When other is null. So this should be a very simple scenario. We create one point. Let's call it, let's do big decimal 0. So we created the 0, 0 point, and I put it in a variable. And let's calculate the distance when the other point is null. So in this case, we would like, we have an exception here. So I'm going to do a set of throws. And I think this will be a null pointer exception. And we have to send here. Here we can see our first implementation of a lambda expression. So this is a lambda expression because what assert throws receives is a assert throws. Let me just show you here. It receives an executable. An executable is an interface that will run something without parameters. So we have to implement that interface, and we do this with a lambda expression. All right. So if we run this test, okay, we have to add the return here. But if we run this test now, okay, the test fails because we are not handling the exception properly. So now I'm going to say objects require non-null other. Okay, so if the other is null, I want this to fail. Try again. Brilliant. It works. So now I'm going to create a new test. Now it's a more interesting test. It's test distance, and we'll have 2 points. So this one, other. So let's remove the assert throws. And the distance between these 2 points should be 1, right? Because we have the point 0, 0 and the point 0, 1. So if you draw this in a Cartesian map, you'll see that the distance for this would be 1. So let's assert equals. We're expecting 1, so big decimal. And if I run the tests, it will surely fail. Yeah, because I'm returning null at the moment. So let's implement this. So how do we implement this function? Okay, the distance between 2 points, if we want to figure out what is the distance between these 2 points, we can use the Pythagoras theorem because between the 2 points, we can draw a triangle, right? A rectangular triangle. And so if we have a rectangular triangle, we can use the Pythagoras theorem to verify the distance. So if you remember, the Pythagoras theorem goes something like this. It's the distance will be the square root of the value of x1 minus x2 to the power of 2. Where is the power here? All right, so to the power of 2 plus y1 minus y2 to the power of 2. So if we want to write this in Java, I already have the formula here. So there's no need for us to write it, but here's basically what we're doing. We have x x1 minus x2 to the power of 2, and we add this to y1 to minus y2 to the power of 2, and then we do the square root of everything. So basically what we did here. So if everything is fine, we should be able to run our test and it should pass. Excellent. Success. All right. So now that we have our point class, let's go ahead and create our segment class. Oh, before we do that, let me tell you why this is a pure function. So we told about how functional programming uses pure functions. And why is this a pure function? But basically, for this, if we use any point as a parameter, if we send the same point over and over and over again, we will always get the same result. There's also the fact that we are not modifying any value here. We're just getting a new value, which is the distance, out of this function. But we're not modifying the internal state of this point or the other point. We're just using the values, and we're generating a new value. So this is why we can call this a pure function. This pure function strictly receives two parameters, the 2 points. But one is the implicit parameter, this, because we're in an object-oriented language. Even though it's 2 parameters, 2 points, and we do the distance between the 2 points. So this is a pure function, and this is what we always want to do in functional programming. So what happens if I want to modify the state of an object? Well, and I want to return that. If we want to do that in functional programming, what we would tend to do is create a new object and then return it instead of modifying the existing one. And the reason for that is that we don't want to modify anything. So now let's go ahead and create the segment. This is here, segment. And let's create it as a record as well. And as I said before, remember, a segment will have 2 points. So we'll create a segment here, and you will have point first and point second, right? And we will want to calculate public big decimal, because we want to calculate the distance as well. And in this case, it doesn't receive any parameters, again, because we have the data here. We don't need to receive any parameters, but we do have parameters for this function, which is the segment itself. So let's do first return. Oh, actually, we said that we want to create a test for this, so let's create one test. Void test distance. So new segment, and we'll have 2 points. New point, big decimal, 0. Let's use the 0, 0 and the 0, 1 to make calculations easier. You can use any point, really, because we're using a mathematical function. So we have our segment, and now let's do assert equals. We're expecting the distance to be 1, So segment distance should be 1. But the test annotation here, so if I run this, okay, missing return statement. Just load it like this. Okay, it fails because we're returning null. So now it's let's implement this. This would be really easy because I already implemented the distance method in the point class. So if I do first distance second, that's it. This should work. Oh, it didn't. Oh, because I am expecting a big decimal here. 1 IntelliJ. Okay. Yes, now it works. Brilliant. So now we have our segment. Let's go ahead and implement our path. So we have path, and let's call it a record as well. So if you look at the presentation, the path is basically a list of segments. So let's create a path. And let's put here list segment. And let's put segments. Import this. Cool. And we also want a distance method for paths. So distance. So what would be the distance for a path? The distance for a path would be the sum of the distance of all its segments. So if we were coding this in an imperative way, what would we do? We would write a for loop, and we would say, okay, let's say for each segment, so we have segment here in segments, and we would have a variable here called distance. And we would have in here segment distance equals to distance plus segment distance. And this would be an implementation. But this is not what we want, right? Because we're using functional programming. So here we're modifying the distance variable. We're modifying it inside this method, so it should be fine. But we don't want this structure here, which makes it harder to understand what's going on. So we will use a different implementation. And let's create a test. Test distance. So let's create new path. And the path is basically a list of segments. So new segment, and we said, for example, new point, big decimal 0, big decimal 0. And another point, big decimal 1. And then a new segment. We can add a new segment to this path, make it more interesting. And this segment could be 1, 2, 1, right? So if the math is right, this should be, the distance for this segment should be 1, and the distance for this segment should also be 1. But I could be wrong, so let me test this just in case. Let's put it in the actually, let's comment this for now. Let's comment this here as well, and let's go to our segment test here. Let's just test this second segment just in case. Segment 2, and let's call it here. And segment 2 here. Let's see if I'm right. I could be wrong. Yeah, I'm good. Yeah. All right, so let's use that in our path test then. Here. So we created this new path. Let's put it into a variable. Now we want to say assert equals and we're expecting it to be 2 because this segment is 1 and this segment is 1, so 1 plus 1 is 2. So the path distance should be 2. Right. So if we use our old implementation, let's see what happens. Let's see if it works. Okay, it works. But let's use a more functional approach to this. So in here, we are going to be using a feature of Java 8 called the Stream API. So if we have the segments list, and we can do a method called stream. This returns a data structure called stream. This data structure represents a stream of data that we will use to process. So the stream is a stream of segments. So all the segments will go through a pipeline now that we will declare. And this is the key word here. We are declaring what we're going to do. We're not saying how it's going to be done. We're just going to declare it. So in here, I can write map. And so map is a higher order function. Map receives a function as a parameter. So if you notice, we're not used to sending function as parameters. We usually send values, but because we're functional programmers now, we're sending a function as a parameter. And this function is a transformation function. We want to grab one item from the stream and turn it into something else. In this case, we want to turn a segment into a value of a distance. So we want to transform the segment into its distance. For each segment, we want the distance. So let's say an easy way to do this would be, let's call it, the segment would be S. And we could say S distance. And that's it. So for each segment, map it to its distance. And this will return a stream of big decimal. You see, it transforms the stream of segments into a stream of big decimals. And in here, we get a warning from the IDE. So what should we do here? What it's saying is that we can actually replace this with a method reference because it's a shorter syntax. We don't really need we know we want to use the distance method. We don't need to receive any parameter. So the only parameter would be the this object. And this is what I call a object method reference. And I have a full video of method references that I might be able to link to you after, if you want to look in my own channel. So there's a lot of explanation on the different method references. So I think that would be really good for you. But in this case, we're calling the distance method for each stream, for each segment. That's what we're doing. And then we're going to we need to do something with this. We need to add them together. We have all the distances now. We need to add them, so we can say actually, let's yeah, we can call a method called reduce. You see, reduce, it will basically turn all the elements of the stream into a single element. That's why it's called reduce. It's a way to aggregate things. And reduce takes basically a binary operation as a parameter. A binary operation is something that takes two parameters. What are the two parameters that we're going to take? One is the accumulator, and the other one is the next element on the stream. So, for example, if we have the distance 3, 4, 1, and 5, the first time we call the reduce method is going to be with 3 and 4. The second time is going to be called with the sum of this, which is 7, and the next element in the stream, so 1. And finally, we call 8 and 5. And as a result, we're going to get 13. So this is what the reduce method will do. It will be called every time until there is no more elements in the stream. So let's do this. Reduce, and we have two big decimals. Let's call it D1 and D2 for distance 1 and distance 2. And basically we have to add them. And again, we have a warning here. And the reason why is because we can also replace these with method references. The good thing about using IntelliJ is that you don't need to know all the rules for method references, because they are sometimes it's hard to understand them at the beginning. So IntelliJ already tells you where you can use method references or not. But I like to know about these things, so that's why I created a whole video about it. But let's replace it here. So now the reduce method returns something called an optional. And now, what is an optional? An optional represents the possibility of not having any value. And why would we not have a value? I'll tell you why. You might have an empty stream. The list of segments might be empty. So what do we do in that case? There's nothing to add. So there are two options. We can provide a starting value to the reduce method, or we can it will return an optional, and we can operate with that optional. So for example, optional allows us to do something if the value is not there. So what I'm going to do is, if the value is not there, give me 0. All right? And let's put a return statement. So you see the difference? This is way more declarative than what we had before. It doesn't have any for loops. It doesn't have any aux variables. We just have the steps that we're going to do. We're going to transform every segment into its distance, and then we will add them together. And finally, if we don't have anything, we'll return 0. Very, very easy to understand. So let's go to our test. And actually, let's write one more test when, let's call it when path is empty. So we would be sending here an empty list. This is collections empty list. And we're expecting in here the value 0, so big decimal 0. And let's run these two tests together. Excellent. It all works. So you see, we were expecting 2 because these two segments have 1 as a distance. So 1 plus 1, 2. And in this case, we are expecting 0 because we don't have any segments in this path. So I hope you're following along. And remember, if you have any questions whatsoever, you can ask them on the chat, and either me, I will respond to them at the end of the stream, or it can be also replied by anyone in the Globant team. Brilliant. So now we are missing only one class, which is the path list. And this path list is going to have a list of paths. Yes, very obvious. All right, so list path. Let's call it paths. And let's import the list path. And all right, so what are we going to do now? We have to create one method that will tell us if this list of paths, which path is the shortest in this list. So why do we do this? Imagine we have this API, this Google Maps API, and we usually, when we go to Google Maps, it will give you like 3 options of different paths to get to a certain point. So there are many options to get to a certain point. You want to know which is the shortest. So we're going to create this function to figure out which is the shortest path. So it's going to be a public method, and it will return a path. For now, we'll just put path here. And we are going to say shortest path. So for this path list, we want to know the shortest path. And all right, so we have a path. We'll have to create a test for this. And test shortest path. Right. Now that we're going to test the shortest path, let's, oh, I forgot this. Test. And let's put here a new path list. I'm going to grab my path that I created in my path test because it is getting longer and longer every time. Mhm. So we have a path list has one path. I'll have to add another path. Let's add one path which will have 3 points, let's say. Oops, I forgot list off. Oof. So we have a list of paths, and the paths are a list of segments. So maybe I'll extract this so it's a bit clearer. So let's name it. Let's name this path. Oops, I extracted it as a method. By the way, when I do this extraction, I'm using Option Command B in Mac to extract a variable. You probably know this, but if you don't, it's a very, very convenient way of creating variables. So let's call it path1. And then we have the path2. And let's extract it as well as a variable. Option Command V and call it path2. And let's change it a little bit. I'm going to put 10 here. So it's very obvious that path2 is longer than path1. I'm going to put 0, 0 here. Okay. So we have path1, path2, and we have a path list with path1 and path2. And let's extract this into a variable as well. Option Command B. Path list. Brilliant. All right. So what do we expect here? What we're expecting here is to have, if we call the path list shortest path, what do we expect here? We're expecting to receive path 1 because it's the shortest. So let's call assert equals. And what are we expecting? We said path 1. Okay. So this is what it should happen. We have 2 paths. We're expecting only one, the shortest. So how do we implement this? Let's if I run this. Oops, I'm not running the right test. Sorry, I'm running. Okay, so it fails obviously because I'm returning null. So what is the shortest path? How do we know what is the shortest path? The shortest path is we have to get all the distances for all the paths and then figure out which one is the minimal. So how do we do that? We have our path list and we can stream it as we did with the segments. Remember, we create a stream of paths because we could either again create a for loop and go path by path and asking is this path shorter than the previous one, and if so keep that one, otherwise keep the one that we had before. And this is a very, very hard way to understand the logic, but with the stream API you will notice that it becomes so much easier to filter things out. And that's why we have like basically one function here which we can use. But first we need to we can use this function min, which will return the shortest path. basically. It returns complete. It will return the minimum in this stream. So it's really convenient for us to use this instead of the for loop with multiple ifs and a lot of things. So and how do we compare them? The min function receives basically a comparator. Comparator is an interface that it has existed in Java since a long time, but we can use we can create new comparators, and now with Java 8 it's really easy to create them. If you use comparator comparing and you tell which field you have to use to compare, so we want to use the distance field from path, the distance method. So if I just need to provide a for a path p, the distance method, and that's it. And now it's telling me please replace this with a method reference, but we still have an error here. So what's the error? Basically, the stream can be empty. So what do we do if it's empty? We return an optional. So in this case, we won't be providing a different value if we don't have any path. We'll basically return the optional. So we'll let the user handle the possibility of the path not being there. So now we have to do something else, because shortest path returns an optional. You see, optional path. So let's assert optional path. Assert, let's say assert true is present. So we can ask the optional, is the value there or isn't it there? If it is present, then we can use the value. So optional get. It's get, using the get method is not very recommended. You can use multiple different methods like map or flat map. But for now, we're going to be using the get method, and because we use the is present first, we can use it. But it's not recommended, and it really breaks the flow of things. But because we are testing, this is fine. Let's so let's run this test, and we should be getting the path 1 because it's clearly the shortest one. If I put here path 2, this will fail because I'm expecting path 2, but it should be path 1. You see, the values are different from what I expect. So let's call it again with path 1. And just as an example, I'm going to write a new test in the case is empty, and the list is empty. So let's remove all this thing, and let's put collections, empty list, and in this case, we are going to do assert false. Value is not present. Let's run this test. And it works. So these are very, very interesting things about using the functional interfaces that Java provides. We're using the stream interface, we're using the optional interface, and this is just the introduction, guys, because we are going to go way deeper than this, and we're going to be looking the optional interface, the optional structure, the stream structure, the completable future structure more in detail whenever we in the next sessions. In all the next sessions, we're going to learn so much more about all this. But this is just the introduction so that you get a taste of it and you understand why this is a really cool thing. I mean, have you ever imagined that calculating the shortest path would be this easy? So, all right. Let's go now to our shortest path test, and we want to write a new method now that will tell us which is the shortest path, but that includes a particular point. So I'm going to copy this. I'm going to call this shortest path including point, right? So basically, I want the shortest path that includes this point, right? So in this case, this won't be the shortest path because this one doesn't include the point that I want. So I'm going to put this point in a variable including point. And I'm going to create a new method including a shortest path, but will receive 1 point as a parameter. So let's oops, I'm going to create a new method here. It will also return an optional because it might be that there's no path that includes that point. And now, what do I do? Basically, I need to stream the list of paths again. And I do need to calculate the minimum. I can reuse this. And remember, we're not worrying about, oh, how do I make this pretty? Now we are implementing. Then we will refactor. So we do need this, but we need something else. We need only those paths that include this point. So we need some sort of way to figure out from this stream of path which ones do include this point. So what I'll do is I'll use a method that we have in the Stream API called filter. And this is a great method. This method receives a function called a predicate. So if you look at this interface, it receives a predicate. What is a predicate? It's a function that will always return a Boolean. So in our case, let P, it receives a path and it will return a Boolean. So P, and we want to figure out if this path includes this point. So how do we do that? Wow, that would be tricky. Just for the sake of clarity here, I'm going to create a helper function called include point. I'm going to create this here. And so here we have this. We need to get from the paths, we need to get all the segments, paths, and how do we get all the segments? That's a tricky one. We can do this using a stream and using a method called flatmap. Wow, now we're going deep. So what do we do? What does flatmap do? Flatmap will grab a collection and put it into the stream. So it maps one object to many, and it puts them all into the stream. So let me show you what would happen if I use just map, right? So we have a path, and this path has segments, right? If we use map like this, we will end up with a stream of a list of segments. Let me show you. If I extract this, you see this is a stream of list of segments. So I don't want this. I want, or do I want this? Sorry, I might want this because I actually, in this case, I do want this. Sorry, because usually what you would like here is to flatten this so that you don't have a stream of list. You can flatten this using flatmap, and you will have a stream of segments. So every segment will get streamlined into a single stream. But in this case, we want to keep the segments. So I'm going to keep the segments all together for each stream. So let's say, yeah, map segments, because we want to figure out if the path has the segment. So actually, no, let's not put this in a map. Let's just put this, let's say filter, and in the filter, we're going to say, oh, this is the problem. Sorry. We're coding live, so I have to send the path here. Right, so now I do have the path. I can say path dot segments and stream. Now filter, and this filter here, we can, what do we do here? Have the path, no, we have to declare a segment. Want it as S, and S, we want to here's what I have to do. I have to say if S first is equals to point, or S second is equals to point. So now I'm saying if the segment includes the point. So segment includes point. And finally, filter returns a string. So that string could be empty. I'll say find first. So the first string, the first path, sorry, the first segment oh no, actually, I'm going to say any match. Any find find any. So any segment available, return it. And this returns an optional of segment because there could be no segment that includes the point. So I'm going to say map, or actually is present so if there is a segment, that means that the path is includes that point, right? Oh, now the IntelliJ has told me that there is an easier way to do this with any match, of course. So let's put it as like this. But let's review it. So first we filter, is there any segment inside this path that includes the point? Yes, no. Then you find any point, and then you figure out if it is present, if the value exists. But of course, there is an easier way to do this. The shortest way to do this is using any match, which is basically a method that replaces the three other ones. So in the stream, if any match this, then we're good. It means this path includes that point. And then we'll do refactoring, of course. But yeah, we have the method now. And if we go to path list test, we said that we want to hear path 2 because that one includes the point and the other one doesn't. So let's run the test and see if it works. There might be something wrong with it. Oh yeah, it works. Brilliant. Just in case, let's see what happens. No, it's fine. Let's see what happens if I change it to path 1, but it won't work. Okay, brilliant. It all works. Now it's time to do refactoring because I don't like the way we have been implementing it. But it was just a way to start working. This is the whole cycle of TDD. We code quick and dirty, and then we refactor once the tests are working. So now we need to refactor this. So basically, I feel like this includes point should be a method in path, right? Because I'm looking at path things. So I'm going to move this method into the path class. So I'm here in the path class. I'm going to make it public. And I'm going to also move that helper method in here. And actually, I don't need to send the path anymore because I have a path. So so you see what I'm doing here, right? I'm refactoring, taking advantage of the object-oriented properties of Java, but this is still a functional method because you see, I'm not modifying anything. There's no modification of values whatsoever. I just operate with those values and return new things, but I'm never modify anything. And that's number one rule. Don't modify anything. All right. So we have this method here as well. Let's run the test and see what happens now. Let's see if I have done the refactoring well and it works. Let's just run all the tests just in case for path list. Where is this path list test? I'll run all the tests and they should all work My refactoring shouldn't have broken anything. Good, everything works. That's the magic of TDD. You can refactor and be sure that you didn't break anything. Okay. So what else? Any includes segment. So now this one, segment includes point. It's pretty obvious that it should be in the segment class. So let's move it. Let's go to the segment class here, and let's just call it include point. Includes point. Includes point, and it should be public. And because we have the segment, because we are the segment in here, we'll remove this. Just say first and second. And in here we'll say S includes points. Doesn't receive an S anymore. You see, everything is getting more and more streamlined. So let's run all the tests again. Oops. Let's run again. Yes. What else? So now we have the includes point. Let's see if we can modify this a little bit more. So we should be now extending this method to not just one point, but actually a list of points. So let's modify this to be a list of points. Right? So I'm going to keep this as I have done it. Like I'm just going to keep the same test case with just one point, but now includes points. And let's just refactor this method name includes points, and these will also receive a list. Points. And this one we should also refactor. Includes list of points. By the way, by refactoring, it's really easy. It's just Shift F6, and it will rename your method in IntelliJ. Or you can just go here and go refactor, rename. You see Shift F6. It's really, really easy. And in here, we also need a list of points. Let's refactor the name. And include this class. We are importing it here. Now it's tricky because we have to figure out if the segment includes all the points. So includes points. How do we figure this out? So we have a list of points. We need to go through the list and figure out if those are included. So let's create a test for this method. We have our segment test. So I'm going to create a test here. Void test includes points. Okay, let's start with a simple one empty. So we have segment empty input list. New segment. We'll copy this one here from here. And we'll do, we'll get this point 0, 0, and we'll ask the segment includes points, collections. Oh, actually, we said that we wanted to do empty list. So segment includes points and collections empty list. And assert true. What are we doing here? We're saying if the input list is empty, then we want the segment to return true, because if I'm telling you, do you include this empty list? It does include the empty list because it's empty. So let's see if this, we can basically say true here and run this. It works, but it works because I'm saying true. But now let's add a new test where we have 1 point. So one point. And in this case, so I'm going to extract this 0, 0. I'm going to say singleton list. So it has to include the 0, 0. And so again, true works. But now I'm going to create a new test when the point is not included, right? So let's create a third point. Let's call it 1, 1, 1, 1. And 1, 1 is not included here. So now we need to make it work. So what do we do here? We have a list of points, so we could again create a for loop and do all that, but as you have noticed now, we want to do it in a functional way, in a declarative way. So let's do it like that. So we have a list of points. Let's go through the list of points, sorry. And basically, we want to figure out if all the points are included in this segment. So what do we do here? Yeah, let's do any all match, and we can do something like what we had before, s distance, s first, it's p equals s first, or p equals second. So let's just put this in a different method called includes point, so that it's clearer. You see, so every point has to be included. That's why we call it all match. Fine. So now we run this. This one we wanted not included, so assert false. That's why it failed. Now everything should work. Excellent. But now I realized that we don't want this method in segment, the one for many points. Why do we don't want it? Because a segment can have at the most 2 points. So if we send 3 points, it will never contain the 3 points. So what we have to do here basically is we'll have to we'll remove this and we'll just keep this one. Just includes point. Okay. So we'll keep this one and we'll remove the empty list case. Let's put it includes point here, 0, 0, and includes point 1, 1. And if we go here, yeah, that's good. So if we run it again, right. So just for the sake of the running of the test, I'm going to do this, but we have to fix that. Okay. Now includes, now we have to fix this. Now we have done a mess. We have segment stream includes point. So we have a list of points now, and we want to figure out if this path includes the points. So how do we do this? Basically, we need to figure out. We need to ask. We need to get all the points in every path. So we need to transform the segments of every path into a stream of points. You see, we have the segments, and then we want a stream, and we want to transform all the points in the segments. We need to get all the points in the segment. So we can do this like this, for example. We have the segments, and I can do segment. I can create a stream of, and I can do segment first, segment second. And this flat map method will put all the points in this segment into one stream. So we are basically getting rid of the layer of the segments, and we are streaming everything as a point. So every path we are turning it into a list of points. Okay, and now we need to figure out if we can use distinct here if we want to filter out all the points that are repeated, because some segments might have the same point. So we can just remove all the points that are repeated, and then we need to filter, and we need to figure out if the points here are contained in this stream, right? So what we can do is one way we can do this is we could, for example, turn this into a list and then compare the lists. But there is no, let's say, there is no way we can, there's no way we can make sure that the order is the same. So another option that we have here is we can transform this list into a set, for example. So we can say new hash set, and if we send this as a set here, set of points, see, now we have, and we turn this into a set as well. And this is points in path. So we need to compare these two sets and see if this set is included in this one. We don't need this thing here because we are creating a set. And we need to compare this set of points contains, points in path contains all set of points. You see? So now we can basically, actually, I think we don't even need this. We can leave it as a list and it will also work. So contains all the points in this list. And now we're good to go. Let's run the path list test. And everything is running. Let's run all the tests in our project. We can do this from here, run all tests, and everything runs fine. So excellent, excellent. This is what we want. That's what we do TDD, that because we are sure that we're doing things right. And when we are not doing things right, that the test tells us. So we are including this. We're figuring out. Yeah, let's go to path list test. Let's see if we are missing any test here. So let's create one more test where we have multiple points, because we have only a test with only 1 point, including, let's say, 2 points. So let's just put in this one as well, including point 2. Let's put it in here. Let's run this. And everything still works. Brilliant. And what happens if there's no path that includes any point? For example, let's go here. And I believe there is we can use the point 1010, for example. Let's call here new point big decimal 10 big decimal 10. So this point shouldn't be. So let's call it not including point. So in this case, we're expecting this to be false because the value is not present. And yeah, we have to remove that one. And let's run this new test. And this should work because if you remember, this will return like that. Okay, so I have a way to refactor this even in a very nice way. So I can, because I'm looking at this is here and this is here. It's all repeated. I don't like that repetition. So let's refactor this very quickly. I'm going to create a new method here, which will be shortest path with condition. Going to be private, and it will receive predicate. Okay, a predicate for points. So what is a condition? So this one in here, we are going to put the condition. So I want to do this refactoring because I want you to see how we can create higher order functions. We can create functions that will receive functions. So in here, we're creating a function that receives a function as a parameter. Okay. So this condition, oh, actually, it should be a path. No. Okay. So now I can replace this with shortest path with condition. I send the list of points, and my condition will basically be this predicate that I have here. You see? And in this case, my condition will be, I can replace this with shortest path with condition. I send the an empty list of points because I don't want any point included, and the condition will be just true. I want this to always be true. So if I test all the tests here, and this is a very cool refactoring we have created in here. Actually, we don't need this here. We don't really need this because we are sending it in the predicate itself. So we don't need, we just need the condition there. You see? Shortest path with condition, we just send the condition here should be this. And in here, we're sending this as a condition. And the points are being sent as part of the predicate. So this is a predicate which has some internal state. It has the points as an internal state. So these points have to be, they can't be modified. But because we're doing functional programming, we're not modifying anything. So this is the beauty of it. So now we have some problems with this. What are the problems that we're looking at this here? There are no problems. Let's run the tests and see what happens. Excellent. So you see how nice these methods are now? They're very concise, very, very easy to understand. Everything is declared. We're saying, okay, I have a list of paths, filter them with a condition, and then return the minimum, the path that is the minimum using the path distance. So easy to understand. and this method itself includes points. Basically, we have we get all the points, and then figure out if all the points in the path are contained, and very, very easy. The same with the calculation of the distance. Get all the distances, then do a reduction by summing them up, and in case there's nothing, just return 0. All very descriptive. And this is a value added that you will add to your team, and they will be very, very thankful that you did this. I have used this kind of language to also to talk with product owners and business analysts, and they find this kind of language so fascinating because it's very descriptive, and you can really describe the business with this. So yeah, I think that is all that we have for the tutorial for today. So before before we leave, let me thank all of you for watching till the end of this stream, and I'm very, very thankful that you have joined. And if you want to keep digging even deeper into functional programming, I invite you to the session next week. It's going to be so good. We are going to learn about functional programming patterns. And this is a more advanced topic because we're going to get the building blocks that we have introduced now, which are the functions, the immutable objects, and the types, the values, the expressions, the higher order functions, everything that we've learned today. And we're going to be learning all about the patterns that we have in functional programming. Maybe you've heard about some of them, like monoid, MapReduce, or monad. These are scary words, but there's nothing you need to be scared of. I'm going to teach you everything about them.